Hey everybody, it's Jeff here for CS161B. We are going to start or continue to learn about arrays. Last module, we spent time talking about the C string or the character arrays, right? And we used some of the reinforcement from last term to learn how to continue to learn how to manipulate strings and start to connect the dots as to the actual structure of that is called an array. Okay, so we're going to dive into that in more detail, talking about arrays in general. And we spent a lot of time on arrays. It's not just this week, but also next week as well. Okay, and so we'll jump right into it. I have some slides as well that will be that are posted here with the video here. Um, and so let's start with kind of some example problems. Um, if you think about code you've written and what you've learned so far, let's say that you want to build a training plan for a marathon or some other big event. You'll have a number of dates, and for each of those dates, you might have a particular activity and maybe a status and a goal and other things. Right now, the only way you know how to do that is to create a bunch of variables, right? What if you wanted to create a stock portfolio and with your stock portfolio every day capture the high, the low, and the average prices for that stock? You could write that today with 3, 4, 5, 10 stocks, but if I asked you to do it for the S&P 500 or for every stock in the NASDAQ, um, there's some missing capability here in what we've covered. You have some high-end collectible item that you want to sell, and so you're monitoring sale prices each month. Oops. Um, and then we'll probably cover this next week more, but Battleship is an example. It's a game with an example where you have a two-dimensional grid, and you want to keep track of things that have happened on that grid. You can think of things other than a game of Battleship that might have a similar type of mechanic where you have a grid and you want to keep track of things on the grid. Maybe it's you're in charge of valet parking or you're a restaurant manager and you got to keep track of where the tables, what time tables are being used and things like that. These are all example problems where the current capabilities of what we've learned so far in 161A and 161B to date don't get us enough. And so we need to use a construct called an array. And if we try to connect the dots one more time here, think about that rock, paper, scissors program that some of you may have used. I've used it before, either like as a midterm or a practice midterm or something like that. What if you had 100 players and you were randomly pairing up players and you were having them play rock, paper, scissors and you were trying to keep track of how many wins each player had? Or just even look at the assignment you just completed, where we were entering items on the food cart. We were typing in items and costs, but we were only keeping track of the total, right? What if I said, print your order? I want you to print my whole order after the fact. We don't know how to do that yet. Okay, all of these methods or all of these examples benefit from this concept called an array. And an array is simply, it's an ordered list of items. And so if you look here on the right, I have 4 items, 24, 0, 42, and 99. They're just random numbers I picked. They're in order, which means the first one's 24, the second one's 0, the third one's 42, and the fourth one is 99. I will determine which one I want to use, either access or modify through what's called an index. And like almost everything in computer science programming, we always start at 0. So the first element, right? This is an element. I should change that to say element. The first element is 24. Its index is 0. The second element is 0. Its index is 1, and so on. We create this structure by basically declaring the array's name, same rules as variable names. We give it a number of elements inside square brackets, and we give it a data type. So in this case, we're creating an array that has 4 elements, and each element is an integer. And we'll talk about some of the rules about arrays throughout this module here. We'll come back to those in some more detail. But let's jump to the replet here. And by the way, I have the book open here. We're covering in module 11, we're covering basically 11.1 through about 11.11. Okay, and like with, I mean, I think this textbook is really good. There's so many examples and so many practice. Your best, you will benefit if you go through all of these, right? Like many of you do. As you figured out by now, most of the examples I show, I make up my own. I sometimes use the stuff in the book, and by making up my own, you get to see more examples, right? Okay, so we're going to do that again today as well. All right, so let's do some basic array lookup. And I'm going to, I'm a baseball fan, and I am going to use some data that I found on this ESPN website, some career data for Miguel Cabrera, who future Hall of Famer player. That myself and my family, big fan of this guy. And so we're going to use some of his data. If you're not a baseball fan, it's fine. You can just follow along, recognizing that what we're going to do is we're going to basically, I'm going to have some of this data in my program, and I'm going to access it in different ways. Okay, and so well, first we're going to create some information around Miguel Cabrera's career. He started in 2003, and he played for 21 years. He retired last year. Okay, and I'm going to create some other variables here that I'll explain as we go. But first, let's go ahead and I grabbed the batting averages for his 21 years from that table. And I'm not going to have the pain of typing those in front of you. So here they are, right? A batting average here is a real-time number, as low as 0 and as high as 1.0. And baseball fans in the crew here know that like these are really good batting averages here. And so so a mixture of really good batting averages and I would say average at lowest, right? These guys are kind of average batting averages. Okay, so we're going to give the user is going to enter the year, and we're going to specify this. We're going to say enter the year between 2003 and 2023. And I'm not going to do any error checking on the year right now. We'll talk a little bit about that here momentarily. Now, in order to calculate the index of this array, what I have to do is I have to subtract the start year from the year that's been entered, right? And so if I enter 2004, for example, then I want this number right here. And so that's the index value would be 1. So I take 2004 and I subtract 2003 and I get an index value of 1. Okay, let's give that a shot and see if that works. Okay, I didn't use that variable yet, so let's comment that out for right now. We'll see if I need it or not. Okay, so we'll go ahead and enter 2014, and I get a batting average of 0.313. Let's go back up here, and we see that that's right there and correct. Doesn't matter whether it matches that. What really matters is if it matches this, right? And that 313 is right here. Okay, so so I entered 2014. I subtracted 2000 from 3 from that, and I got an index of 11. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I get my number there. Okay. We'll talk about this throughout this lesson. Let's look at what I did here. Okay. I initialized my array with these numbers, but notice that I specified 21 entries in the array. This array is specifically designed for a player who's had 21 seasons. For a player who's had fewer or a player who's had more, this is not going to work, right? And so, but it's a very important point, right? If I wanted to do this instead, this is not going to work. You cannot assign the size of your array with a value that's not known until you run the program. That's called dynamically declaring the array. You must statically declare it. Okay, so one way, so I'm going to make some notes here so you can follow along. So you cannot dynamically declare an array. So this does not work. You can use a constant, right? So what I could do is I can say cons int max years, and I could say 50. I could say that maybe that I think that in professional baseball, the most number of years a player will play will be 50 years. Okay, so let's see what happens if I do that. Okay, that's still unused, so let's comment that back out again. Okay, so now it's working again. So this gives me the flexibility to have players with only 1 year of stats and players with up to 50 years in stats. I don't think any professional baseball players played 50 years. So this number is more than needed, and it will result in a lot of wasted space. So that's a trade-off that you have to decide here, okay? And so this definitely is more robust because now I can add, like if I want to change the player and I want to change to a player, who's played more years, Cal Ripken Jr., for example, and I want to put that in, right? Pretty sure he played for more years. I could put that in, right? And so something to keep in mind. So we use the constant there. Now let's try this. I said that I didn't do any error checking on the dates. What happens here if I enter a date that's before my range here? I get an answer of 0. I guess that's technically correct, right? Technically, he did bat 0 in 2000 because he wasn't playing. But those zeros are coming from somewhere, right? Fortunately, it's the right number. I will tell you that if we run this maybe on a Linux system, we might not get zeros. We might get error messages. We might get zeros. We might get something else. What happens if we pick a number outside the array in the other direction? So look what happened here. In 2038, I was still in this 50 years, right? And so all of these numbers that are missing here are all zeros, right? In fact, if we go exactly to, that would be 2052, I should get a 0. But as soon as I go 1 year further than that, I get basically random data. And that's because what's happening here is I'm accessing a piece of memory that has data in it from who knows what and who knows when. It could be previous Replit sessions. It could be another browser tab. It could be some other document. Who knows what it is? And this is an issue because if I do 2053, 2054, 2055, and I write down all these numbers and I convert them all into binary and then I convert them into maybe ASCII or something, I might find something, right? I might find a text file with your credit card number in it, right? And so we are accessing the array out of bounds. And as you can see, sometimes you get zeros, sometimes you get random data, and sometimes the program will not work. And I'll show you all of these, right? So what you're seeing here is random data here. Because my data type here is a double, we're seeing super big numbers and super small numbers because it's just it's 80 bits of, I think 64 bits of why, you know, the way the floating point format works, these exponent values can be very high or very low. We could keep picking numbers and, you know, we'll get some other, you know, who knows what we'll get. Looks like if I go higher enough, you know, there's some point where I get back to zero again. So you can't count on this as a predictability thing, is my point here. And if you're trying this program on Visual Studio Code or you're trying it in Linux, you might get different behavior. Okay, so that takes me back to this next slide here when I want to talk about these two rules here, right? Each element of the array is the same data type. Okay, so we jump back to the code here. I have declared this array as an array of doubles. So each element has to be a double, right? I can't declare an array that some of them are ints and some of them are doubles, and some of them are chars and some of them are booleans. I can't do that. Right? So each element is the same data type. And like I've said, you have to statically declare the array. Okay? And we will learn ways to work around both of those constraints a little bit in this class. But when you get into CS260, that's when we really go and we learn about data structures and how to do arbitrary structures of holding anything in any way. And you really get the tool set to do whatever you want around how you organize and store and access your data here. Okay, I am going to clear out this for a moment here. We'll come back to the baseball example a little bit here, but I want to talk about how we initialize arrays, right? In the baseball example, in the previous example, I initialized the array with a single statement. Kind of like this. Example 1, and I used curly braces to initialize all 3 of my elements. Okay? If I run this code right now, it runs, but then it tells me I can't use the it says I'm not able to use, or I haven't used the array. So let's go ahead and print out the array. In order to print an array, you basically need to loop through it. You can see I'm mixing languages here. Keep wanting to put commas there. Okay, so this should work. Okay, so you see I print out my 3 elements. I have to loop through it, and in my loop I need to know the size. Now it's better convention to have a constant variable here, and so we can do that. Because then I could change my size at will. Okay, you can also an element at a time. So we can declare the array like this, and then I can say ex2 of 0 equals negative 99, ex2 of 1 equals negative 88, and ex2 of 2 is equal to 3. And now what we're going to do is we're going to add ex2 to my print statement here. And if I run this, you'll see I get, actually, no, let's not do it that way. That's harder to read. We'll do array 1, and then we'll do another print statement with array 2. This will be easier to read. You can see my first one, 99, 88 minus 3, and my second one, I just changed the signs of all threes to show this. So you can modify initialize in different ways. And there's an important distinction here. If I try to do this, if I try to change this, you can see what happens here. I'm able to change the third value, and I can do that for either array. Okay, but the point is if you use this initialization, you have to initialize everything. Right? So if I change this to a size of 4, okay, you can see what happens here. In this case, ex1, I've initialized this and it defaults this initialization of that fourth position to 0. But in this case, it doesn't initialize this one to 0. Okay, but then if I try to do this, I'm able to initialize. So you can kind of mix and match here, but this will always be left to right, 0, 1, 2, 3. Right? If I'm only initializing 3 of my 4 positions, it's always starting at the beginning. Okay? And so C++ is terrible at letting you access uninitialized elements of an array and going out of bounds. It doesn't let you do that with other data types. Right? If I just try to say x equals, if I try to just see out x and I haven't initialized it, it'll yell at me. But if it's an element of an array, it doesn't do that. So you have to be very careful when you're using arrays and pay attention to the bounds. Generally, you're not going to have big initializations of arrays in your code. There will be some arrays where you'll initialize in your code. So for example, you might initialize a string of, a 12 element array of strings, which are January, February, March, April, May, June, and so on. Or you might initialize a 12 integer array that's 31, 28, 31, 30, etc., the number of days in a month. Or you might have an array of the atomic weights in the periodic table or something like that, right? But in most cases, you're going to get your data from the user. Okay, so let's walk through this example here. You'll get your data from the user or from an example file. We will get into reading data from files, and I think, we'll come back to this ESPN page perhaps, and we'll read that data and do stuff on that in a future lesson here. So generally speaking, okay. So let's do an example of getting user data from the data from the user. Let's not fall into the trap of creating all these variables at a time and then getting error messages. I'm going to create a sample array, an integer array called sample. And I'm going to have the, I guess we want to do it one at a time, kind of like that. So let's create a a variable called inval. And then we'll say while, and we're going to create a variable called index. Set that equal to 0. And we're going to say while index is less than 10 and inval is not equal to 0. Okay, so in other words, I'm going to enter up to 10 numbers. And so while I'm in my loop, as long as I haven't entered 10 numbers yet, right, and I have my current value is not a 0, that means this number I want it process. So I'll do two things with it. I'm going to add it to a sum. So we'll create a variable called sum and we'll initialize it to 0. And I'm going to increment my index value by 1. And then I need to ask my prompt again. Now, those of you that saw my videos last term, you saw that I would do this type of looping in different ways. Sometimes I would have the enter and input as the first lines in the while loop. Sometimes I would enter it once and then enter the while loop. Again, lots of different ways to do this. The point here is what I'm doing is I'm giving the user the chance to enter numbers one at a time, and under two different conditions, we will exit the loop. Okay. And then I can say our total is let's see if this works. Oh, that's funny. Sample of index equals inval. I forgot to assign it to the array because I haven't used the array yet. Okay, so our first number, our second number, our third number, and then I type 0. That addition looks right. Let's try 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have a bug here. And I have a bug here because I'm starting at 0 and I'm incrementing after. So this really has to be 9. Because I'm starting at 0. I'm incrementing after I process the value. And so if my index is 9, that's my 10th number. And that's when I would stop. Okay, now let's process the array. So I'm going to declare a variable called max, and I'm going to set it equal to the first element of my array. And then I'm going to do a loop. And we did max and min functions last class, so you should be following this, except we're just using an array here instead of user input. Okay, so what we've done here, max value is at position. What we've done here is we've set the max value to the first element in the array, and we've set 0 the index. So we've said the value that we think's max is at position 0, and its value is that value. Then I'm going to loop through, and I'm going to check each element. If the element is larger than the maximum, then I set my new maximum to that value, and I set my new max index to that position. I can actually start at position 1 because I've already done position 0. And let's see if my endpoint is correct. There are So index should be our values. So I'm going to do 10, 20, 10, 40, 20, 0. Okay, our sum is correct. 10, 20, 30, 40, 80, 100. 1, 2, 3, 4, 5 values in the array, and my 40 at position 3. Position 0, position 1, position 2, position 3. Now, depending on what you want to print, you might want to add 1 to that index, right? Because you might want to say the 4th element. Because this is the 4th element, but it's in position 3. Okay, one more thing I want to show you. If I just enter 0, look what happens. And my total is correct, my 0 value is in our array, but my max value is incorrect. And so in other words, max of or sample of 0 has some data here, right? If I do this, in fact, I'll just do a few random values here. Can see that I do have a 39. These happen to be zeros. If you're doing this at home, you might get different values than me, right? So how do we fix this, right? We basically have to say if index is greater than 0, you didn't enter any data. That should fix that, right? And in fact, you might want to do that earlier so you don't print a total and there are 0 values in the array, right? So generally, you want to do your errors checking in the right sequence so you don't print extraneous stuff, right? Okay. And so, so this is an example of accessing elements in the arrays. You generally will use loops, right? You'll use for loops, or you can use while loops, right? And you could, of course, use for loops where you don't have to start at the beginning. You don't have to end at the end. You can go in either direction. You can, you can bounce around based on different rules and whatever you're trying to do. Okay, for example, if your array has a bunch of elements that are in order and you wanted to find a certain value, instead of starting at 0 and going one at a time, you might start in the middle and then decide to go left or right, Much like the guess the number game. So different ways that you can do things. Let's do another example. That what I just typed might look familiar to you. What I'm doing is I'm setting a seed for my random generator, so I'm not generating the same random numbers in order. And what I'm doing here is I'm creating a large array, 10,000 values. Yeah, let's make it 1,000,000 values for measure, right? Let's make it large, right? And what we're going to do here is we are going to set each value to a random number between 0 and 100. All right, so remember, let's make it between 0, let's make it between 1 and 100. It's a little bit more intuitive, I think. Between 1 and 100, inclusive. All right, so I've created my large data set. I'm going to run that here in a moment. And what we're going to do is we're going to do some analysis on this. We're going to say enter a number, 100. And we are going to so what we're going to do is we're going to compare each element to that value. And each time we find that value, we're going to increment a counter called numFound. I found val numFound times in the data. I think that'll work. Okay, so let's enter a number. I'll enter 24. And 24 was found 9,963 times in the data. Let's do it again. Well, this time just over 10,000. We're doing a million data sizes. Or our data size here is a million. Or sorry, our array size is a million. There's 100 different values in there. So it kind of makes sense that whatever value I enter, I'm probably going to get about a 10,000. If I have a good random distribution, right? I'm going to get every number is going to be about 10,000 times, right? And of course, there's a chance that I find something and it's 20,000, right? It's random, right? But there's no way for me to check to see if this is working unless I print out the data and I do a checker there. But I think this illustrates, I mean, it is working, right? And it kind of illustrates what we're trying to do here. We can, that's a million. Let's make it a billion. Program doesn't stop, it stops. Why does it stop? I must be memory limited or something here with this free replet. I've run out of some capacity. So now I changed my number to 100,000. I have a 100 different, so I'm going to be around 1,000 now. That's funny. I'm not sure that's happened to me before where I've hit my my limits here on Replit. Been running this session for a while. I should move to VS Code maybe for next time if I'm going to do some really big stuff. So this is an example here about how I'm initializing the data in a different way and how I'm searching through. And in this case, I'm searching through the entire array every time, and I'm looking at every value. Okay. I want to talk about range bound checking again. Remember earlier in this video, I was entering years out of the range that he played, and I got random. Sometimes I got 0, and sometimes I got random data, right? But now if we go and look at Replit here, and let's look at it's 11, what is it? PowerPoint 11.2.3. No, that's not right. Oh, I didn't put the right, here it is. Yeah, it is 11.2. If we look at this here, this example here, in this example, I've declared some weights. I have declared weights to 3. So I've declared 3 weights. By the way, these numbers that are used in the Xi books here, they're just showing locations. They're just showing random, not random, but sequential locations in memory. They don't really mean anything. But what this is showing here is that if I assign user weights 3 to a value, instead of writing into user weights 3, it writes into the next space in memory, which happens to be the variable user age. And so it changes that 44 into 199, right? And so when we print the user age, we get 199. Now, if I try this code in Replit, let's see what happens. Ugh, sorry. Okay, that failed. Let's try that again. It complains, right? It complains about it. So Replit is really good here about this. Now what I can do here, let's see if I can fool it. I need to get rid of the error here that I'm using that. And if I do that, program should run. Okay, so far so good. Now, so Replit doesn't let me directly do this, but what if I do this? It let me do it, but it did not overwrite 44. Okay, so Replit is storing this data in a different way than in this example. And you can really experiment, right? What I'm going to do here, j equal 4, I'm going to try something here on the fly. I haven't tried this yet. I'm going to assign, I should do 3. 3, 4, 5, 6, I'm going to just assign over and over here and see what happens. I still haven't overwritten that 44. Okay, so this user age, even though it's right after user weights here in this code, in the book, it's putting them in memory right next to each other. But in Replit, it's not doing that. And we'd have to do a lot of kind of research to understand how Replit stores the data. You might try this in a different environment and you might see different results. Or the other thing that might be happening is Replit is just doing some bounds checking that we're not aware of. Okay, and I want to show this because you're going to develop programs in one environment and I'm going to run them in another or vice versa, right? And we might see different behaviors. We've had nearly zero risk of that so far. And in fact, I used to be a stickler in these classes that said you must develop this way. If you develop on Xcode, or if you're on a Mac doing this, or you're on this version of Visual Studio's, all bets are off. I used to have kind of that disclaimer and said that you better run your program on the exact same thing that I'm testing in. It's become much less of an issue in the last years, but it still can be an issue when it comes to array bounds because different development environments and different compilers will handle things differently. So it's worth us kind of pausing on this to make sure you are aware of this. We see different behavior in this example than we do on Replit here. Okay, so enough on the bound stuff. All right. So one of the things that's common here, it's common to use multiple arrays to connect data together. So for example, I might have a first name and a last name. And with the first name and the last name, I'd have a birth date. And I might have an address. And I might have a net income. And I might have a tax bracket number and a zip code and other things. This is commonly called parallel arrays. And in fact, if those of you that took CS160 in that last assignment, we did use two parallel lists, or the requirement was you use at least two parallel lists. And so you did something kind of like this in Python here. So we're going to go back to our Miguel Cabrera example here. And I've same code here, but I've added the number of hits per year from that same data here, right? So you can see the number of hits are integers. A good season for a baseball player, a really good season is 200 hits. But in the 180 and up, right, is a good season, right? And you can see some really good seasons here over these numbers. And so we can do the same code here. Let's remove that and remove that for a moment. And let's do the same thing. And if I pick a year, 348 in 2013 with 193 hits. And now we go to 2013 over here and we find there's our 193 hits and our 348 batting average. Okay, you can use this data, right, to do whatever analysis you want to do. And so usually it's done in the other direction here. Usually you calculate the average, but we can calculate how many at-bats he had based on the math here of at-bats is equal to the number of hits for that year divided by the batting average for that year. And then print out, I'm not going to type that. So let's try that. So 554 at-bats during that year. Let's see if that's right. 555. Okay, so my code has a rounding, there's a rounding mistake here. Not a mistake, I should say, but the batting average, I don't know if Major League batting averages are rounded down or up, but we have a rounding error here, basically. And so I'd have to dive into that a little bit more detailed, right? I think if we take the, well, we can just do that, right? We can take the 193, I have my calculator here, 193 divided by 555 is 347.7. So because this average has been rounded up already, it's not accurate. It gets the benefit of saying, oh, we had one less at bat to make that average look that much better, basically. So normally it would go in the other direction. Normally the average is calculated. You wouldn't have it in the data. You'd have your at-bats and your hits in your data, and you would calculate your batting average. I just did it reverse because of the sequence of where, kind of how I went through the material. Okay, so now you can imagine here, being able to have all this data and being able to say, okay, enter the player, okay, enter the year, and then print out all this stuff. And then, okay, I want to compare Miguel Cabrera's to Albert Pujols in 2017. I want to compare their data, right, and see, who had the lead in the number, who had more doubles that year, for example. And that's a type of code that we're not that far away from, right? What's missing here is how to basically read in all that data from an external source versus copying and pasting and entering it manually like this. Okay, if my baseball example was too complex because I'm trying to do a number of things and baseball may not be something that as familiar to you, then if you go in here to 11.3, here's an example of postage costs. These numbers are in cents, right? So 112 would be $1.12 per ounces. And I don't know if this, it says UPS 2017. So this is old data here, right? But it's basically, this is how much it would cost to mail that many ounces in what used to be called first class mail. I forget, they just renamed it. USPS just renamed their Ground Advantage, I think it is, or something like that, their first class mail. So, and then you actually can go to 15 ounces now as well, right? So this example is kind of out of date, but it's a maybe a more simple example here, okay, where we're able to compare. We're in this case we're using one piece of one array, one element of the array to get another element in the array. In my baseball example, I was using both elements of an index of an array to calculate something else. Those are the types of things you can do with arrays. Okay, let's talk about how we modify arrays, right? Modifying array elements is really no different from modifying any variable. So I'm going to create a simple array, and I'm going to print out the array. Now you see this type of code is common code here, right? I have a header, I print my array values one at a time, and then I print an end line, right? If I had my end line here, then I'd have each value on its own line, which maybe you want to do, right? But in my case, this is what I want to do. We're going to talk about how to put this in a function here in a moment here. Okay, let's do this one step. I think we're going to do this first, and then we'll move on to functions. One or two other things. Okay, what we're going to do here is change all odd numbers to 10x their value. And so in order to do that, we need to run a for loop. And we're going to say if A1 value at that index, if we do the module division and the remainder is equal to 1, then our number is odd. We learned this early on, right? If the number is odd, then we're going to set that element's value to 10 times its value. And now we can replicate my print statement. And you can see here my 1 turned to a 10, my 3 turned to a 30, and my 5 turned to a 50, and my 4 and 2 remain unchanged. Okay. I'm going to change this and say, I'm going to say, okay, enter one index to change. So I'm going to change index 3 to 99, and you can see 0, 1, 2, 3, right? So you can do it in a loop. You can do it ad hoc. You can get it from the user. That's so you can simply change. You don't have to change every element. You don't have to even loop through it. You can surgically get values from the array and surgically modify values from the array. Okay. Copying an array is similar. Okay, you cannot do this. That will not work. Doesn't like that, right? People might try to do all sorts of weird stuff. Like, well, maybe that'll work, right? Doesn't like that either, right? You can't do it, right? So the way you do that is you have to declare the second array, and you have to copy each element individually. Okay, so you can see I've copied my array here. Okay, this is an actual physical copy, right? It's not like a reference copy, which means if I change A1 of 3 to 99, and I change A2 of 1 to 200, you see that I changed them individually. Okay, let's do a copy in reverse. To copy in reverse, what I do is I'm going to change the value. I'm going to do the value. So if I is 0, I want to put that in the fifth position, which was index 4. So that's our length of 4, which is the array size minus 1 minus I, is equal to A1 of I. This type of stuff takes practice. And if this doesn't make any sense, draw it out, right? If I is 0, then 5 minus 1 minus I is 4. So I have my 0 and my 4. If I is 1, then 5 minus 1 minus I is 3. I think my camera is not mirrored, so this should be 0, 0, 4, 1, 3, 2, 2, and so on, right? Let's see if that worked. Five, 4, 3, 2, 1. This kind of stuff takes some practice. But it's very simple. You can see it's just a single line to copy and reverse as well. Okay. There are library functions to duplicate arrays and things like that, and it's kind of in a more advanced topics that are kind of outside the scope of at least the class right now. Okay. I think I want to talk about next is about passing arrays into functions. Okay, remember that last week we did this, right? We passed in the array and we demonstrated that actually, what we're going to do is we're going to keep all that code. We're going to create a function called print array. And what we learned last week with C strings is the array that was being passed in to the function just had the empty brackets. We didn't specify the size. But in this case, I'm going to give it a second parameter, which will be the size. And so in that case, what we'll do here is we'll take one of our print statements and let's get rid of all of this. See, we get the same results here. Okay, and so you can add a parameter here, which is like, what do you want the table to say, right? Like instead of it just saying array here, array here, array here, I could put a string here that says, you know, number of hits or high temperature or whatever in my print statement if I want. Let's see what happens here if I do this. I thought I was going to stop talking about bounds checking, but I decided to show one more example here. You can see what happens here. I could print smaller than my bounds, no problem. But if I print larger than my bounds, you can see I get all sorts of wacky stuff. Okay, this is interesting to look at, right? You might notice some patterns here. If you look at this pattern 32767, you see a lot of 32767s there. Those of you that know your powers of 2 know that that is 2 to the 16th minus, or no, sorry, 2 to the 15th, right? Let's double check that. 2 to the power, 2 to the 15th power minus 1 is 32,767. So this just shows that there's some memory that are a bunch of ones all in a row for whatever reason, right? And there's no doubt in my mind that maybe some of these other numbers, if we can find some that are that are here multiple times, are going to be similar here. You're going to see different results again based on what you're doing here. But this is another example where my bounds checking, you got to do your bounds checking, or else you're going to get unpredictable information here. Okay, so that's passing arrays into functions. Let's see, I have one more slide here. Just as a recap, arrays are passed by reference. They don't need the size, but like I just did in this example, you're likely going to want to pass the size separately as a separate parameter. Arrays cannot be returned, right? So remember that in this code, if I modify anything into print, I end up modifying whichever array I pass to it. Because they're passed by reference, I can't return an array. So if you want to modify arrays and functions, you simply pass them by reference and you modify them. Okay? If you want to pass an individual element to a function, that's no different than passing any variable, and that could be passed by reference or by value. Okay, so if I find I want to pass, array A1 of 4, I could pass array 1 as 4, and that's no problem. Okay, there's one more thing I want to show you. I think it's just one more thing, and then we will be done with this module. In the book, there's tons of practice. Practice, practice, practice. So you get all the way up through 1111. There is in here somewhere, more on the out of bounds errors here. No, it's 11.7, sorry. Yeah, here's another example of what I was trying to show you earlier, right? Trying to declare the array here based on getting input doesn't let you do that, right? And this one I showed you as well. Okay, so just another reminder on that. I want to show you a common error that I see a lot here. We're going to create an array. And I just put some numbers in here. And I set a target value that I want to find, and I set it equal to 0 to 7. And a Boolean flag. So basically I'm going to write some code that's going to go through the array, and if I find the value, I'm going to set my flag to true. So there's the code. I see this type of code all the time. Okay, so code seemed to work, right? I wanted to search for 7. There is a 7 in here, and I found it. Now watch what happens if I put 7 in the middle of the array instead of the last element. It no longer works. Okay? And I see this type of error a lot because students will take the sample data and it will work for the first element in the array or the last element in the array, but it won't work for all elements in the array. And I will test your code in all sorts of wacky ways because I pretty much almost can always guarantee that I will break it. I will find a way to break it. And so the problem here is that I set my found value to true, but then in the next instance, since I have an if else here, I basically unset it and I send it back to false. So you want to think about this type of structure if you're doing it on every element of the array. Sometimes all you want to do and all you need is that. And now it'll work because you never, once you set the flag to found, it won't get set unset. And in fact, you can even go a step further and you could break out of the loop once you find it. So that if this array was really 10 million elements and you found what you needed in the 7th element, there's no reason to search the remaining 900,000 or 9 million plus elements. So stuff for you to think about here about how to make your program more robust. In many cases, the less code, the better, right? And sometimes you will need to have this if-else's in your for loops. But in many cases, you're only checking one condition, like kind of one side of the condition, if you will. Okay, so that's where we're at for module 11. If we go back here real quick, I should have done this first here, right? So for module 3, right, we've learned arrays. We've talked about, creating arrays, iterating, functions, and we've talked about out of bounds errors here. And we've gone through the first 11 chapters here. Sorry, sections of chapter 11. Okay, in the next module, maybe, there we go, is arrays part 2. Okay, so in arrays part 2, we are going to talk about two-dimensional arrays and some more advanced stuff. Okay, so I stopped specifically here at section 1111 here, and there's some more things for us to look at here in the next module, and that video should be up and running here, in the next week, maybe less. And as always, questions, comments, suggestions, let me know, and talk soon.